Mastering the architecture of an AI-enabled Microsoft 365 environment is no longer just it's not a nice-to-have skill anymore. It is the absolute baseline for modern IT infrastructure.
Yeah, that's exactly it.
We are plunging directly into the core mission of this deep dive today. No fluff. We are doing a ground-up breakdown of the AB-900 Copilot and Agent Administration Fundamentals exam.
Right. And we are focusing intensely on what it actually takes to support, secure, and really protect these highly advanced AI systems.
Because whether you're an aspiring administrator gearing up for this exact certification or, you're an IT veteran who's just been tasked with rolling out Copilot to thousands of users, you have to understand the stakes here.
You absolutely do.
Understanding the intricate web of Entra ID, Microsoft Purview, and Copilot agents is quite literally the difference between a highly secure, frictionless AI deployment and a catastrophic headline-making data breach.
That is the unfiltered reality organizations are facing right now. I mean, when you introduce an AI engine like Copilot into your environment, you aren't just deploying a new app.
No, not at all.
You are introducing a tool that has the capability to access, synthesize, and surface corporate data at an unprecedented, almost, well, frankly, terrifying scale.
All right.
If your underlying permissions, your data governance, and your identity security are flawed, Copilot doesn't fix those flaws. It weaponizes them.
It weaponizes them. That's a great way to put it.
It will surface every piece of overshared sensitive data your users inadvertently have access to, and it's going to do it at the speed of light.
Yeah.
So mastering these administration fundamentals isn't just about passing a certification exam. It is fundamentally about safeguarding the entire intellectual property of an organization.
Okay, let's unpack this. We need to start at the absolute foundation, which brings us to the first major pillar of this architecture.
Core Microsoft 365 services and identity foundations.
Exactly. And if you're tracking along with the exam blueprint, this accounts for roughly 35% of the focus. And the absolute bedrock of this foundation, the place where every single security conversation has to start, is the Zero Trust security model and Microsoft Entra ID.
It really all begins with zero trust. If we connect this to the bigger picture, traditionally, network security was built like a medieval castle with a moat.
Right, the old perimeter model.
Exactly. Once you authenticated and made it inside the corporate network, maybe through a VPN, you were trusted. You had the run of the castle. Zero trust throws that entire concept out the window.
Completely.
It operates on three unyielding principles: verify explicitly, use least privileged access, and assume breach. For Copilot, this framework is critical. But before we get to the AI processing prompts, we have to understand how we establish identity in this zero-trust world.
Which means drawing a very sharp, clear distinction between authentication and authorization.
Right.
And that's a distinction that trips up a lot of people, even experienced IT folks. So let's break that down for you. Authentication is simply proving who you are. It's the bouncer at the door checking your ID.
Yeah, checking your credentials.
Right. It's the process of verifying identity, typically through methods like a password combined with multi-factor authentication, or MFA. Authorization, on the other hand, determines what you are allowed to do once your identity is proven.
And Microsoft Entra, which really acts as the central nervous system for identity in this entire ecosystem, it handles both, but they are highly distinct steps.
Very distinct. When a user logs in, Entra authenticates them. But when that user goes into Word and asks Copilot to summarize a highly classified document, Entra and the underlying Microsoft 365 services must authorize that specific action based on the user's granular permissions.
Exactly. The bouncer lets you in the building, but authorization determines if you have the key card to enter the executive suite. And Entra makes this incredibly seamless for the user through single sign-on, or SSO.
Which is a massive operational benefit.
Huge. Once a user authenticates securely into Entra ID, they are granted a token. This token is what allows them to access Exchange Online, SharePoint Teams, and ultimately Copilot without having to re-authenticate for every single application.
It reduces password fatigue.
Which, ironically, improves security. Why? Because users aren't writing down 50 different complex passwords on sticky notes attached to their monitors.
Yeah, we've all seen that.
In Entra, we manage this access architecture primarily through two core security objects: users and groups. Individual user accounts represent the human entity, or, as we'll discuss later, sometimes the non-human entity. Groups are collections of users, and they are the absolute best practice for assigning permissions or licenses at scale. You never want to manage permissions one by one.
Which brings us to the why for the exam. Why is zero trust so critical specifically for Copilot? Let's think about it. If you don't verify every single request explicitly, Copilot essentially becomes a high-speed vector for unauthorized access. Copilot acts on behalf of the user. It assumes the user's identity when it queries the backend.
Precisely. Copilot has no independent permissions. If a bad actor compromises an identity, let's say they phish a user's credentials and bypass MFA and there are no continuous checks in place, that bad actor now has the full, unbridled analytical power of Copilot to scour the organization's data.
They don't have to manually click through SharePoint sites looking for financial data.
No, they just type summarize Q4 revenue projections into Copilot. This is exactly where conditional access policies come into play. Think of them as the intelligent gatekeepers standing between the user and the data before an AI prompt is ever even processed.
How exactly do they work under the hood?
A conditional access policy evaluates a massive array of signals in real time. It looks at the user's identity, their physical location, the health and compliance status of the device they're using, the application they're trying to access, and the real-time risk associated with that specific sign-in attempt.
It's pulling all this together instantly.
Instantly. And based on that holistic evaluation, the policy makes an automated decision. It can allow access, block access entirely, or require step-up authentication, like prompting for a new MFA code.
Let's contextualize this for the listener. Picture this scenario. You're the administrator for a global firm. It's Tuesday morning, and you get an urgent ticket. A high-level executive is attempting to log in to access Copilot to prepare for a major board meeting, but they are suddenly blocked. The system throws a risky sign-in flag. As an administrator, how do we systematically troubleshoot this specific issue? Where do you even begin?
This is a classic administrative task that you will absolutely be tested on. First, you don't panic. You navigate to the Microsoft Entra Admin Center. Your first stop is straight to the sign-in logs.
Right.
You search for that specific user and locate the failed sign-in attempt. The logs are incredibly granular. They will tell you exactly what happened. In this scenario, you might see that the authentication actually succeeded. The executive typed in the correct password, and they even satisfied the MFA prompt. But a conditional access policy blocked them.
So you click into the specific conditional access tab for that log entry to see the breakdown.
Exactly. You open that tab and you see which specific policy was triggered. Let's say the executive is traveling and logging in from an unfamiliar IP address in a country they have never visited before. Microsoft Entra ID Protection evaluates this context.
It's looking at the travel time.
Right, it looks at the time since their last login in New York, looks at the new login in, say, Tokyo, and flags an impossible travel scenario. It immediately elevates this to a high sign-in risk. Now, your pre-configured conditional access policy states that if the sign-in risk is high, access to all Microsoft 365 services is blocked. Copilot access is severed.
So how do you resolve it?
To resolve it, you first verify with the executive through out-of-band communication like a phone call that they are genuinely traveling. Once verified, you might instruct them to use an approved, corporate-managed device that satisfies a different conditional access policy, or you might have to temporarily adjust the risk parameters for their account, though that is obviously less secure.
You also want to check the user's multi-factor authentication status in this scenario, right? Was MFA actually triggered by the impossible travel, or did it skip it and go straight to a block?
You absolutely check that. And finally, taking a step back from the individual incident, as an admin, you should regularly consult the Identity Secure Score in Entra ID.
That's a huge one.
It is a crucial metric. This score gives you a numerical representation of your overall identity security posture. It acts as a consultant, providing actionable recommendations. It might say, hey, your score will jump by 10 points if you require MFA for all administrative roles. It's designed to help you prevent these risky sign-ins from becoming actual breaches.
Speaking of administrative roles, that brings up the concept of privileged identity management, or PEM. If we are operating in a zero-trust environment, we clearly don't want administrators walking around with global administrator rights 24 hours a day, 7 days a week.
Absolutely not.
PIM is the solution to that. It allows us to grant just-in-time access. If I need to configure a new Copilot agent or change a tenant-wide setting, I don't just log in with God mode enabled. I have to request the necessary admin role through PI.
You might have to provide a written justification for the request.
Right, and depending on the setup, I might need another admin to approve it. Once approved, I get those elevated rights for a specific window, say 4 hours, and then they automatically expire. Furthermore, every single action I take while elevated, and every action any user takes, is recorded in the audit logs. Reviewing those audit logs is a critical administrative skill for ensuring accountability.
PM is the literal embodiment of the least privileged access principle of zero trust. You only have the privileges you explicitly need exactly when you need them to perform a task and not a single second longer. It drastically reduces the attack surface.
Now, I always try to think about where the system breaks down or where the hidden traps are. What about the edge cases for this? We talk a lot about human users, executives traveling, admins using PM. But what happens when non-human identities, like app registrations and enterprise apps, attempt to interact with Microsoft 365 services? They obviously can't use traditional MFA.
That is a highly relevant edge case, especially as organizations increasingly build custom applications or automated workflows that interact with the Microsoft Graph. Non-human identities, which are represented by app registrations and service principals and Entra ID, obviously cannot pull out a smartphone, read a text message, and approve an MFA prompt.
So how do they authenticate securely?
Instead, they rely on client credentials. These usually take the form of client secrets, which are essentially long passwords or, much more securely, certificates. In Entra ID, you configure an app registration to define the application's identity and grant it specific API permissions.
And the risk there is?
The major edge case risk here is credential linkage. If a junior developer accidentally hard codes a client secret into a script and pushes it to a public GitHub repository, a bad actor can scrape that secret, use that service principal to authenticate, and access M365 data.
And it bypasses conditional access.
Because it's a non-human identity, it completely bypasses your standard user-based conditional access policies that look for location or device compliance. This is why securing non-human identities with workload identity federation, enforcing certificate usage over secrets, and strictly monitoring their sign-in logs is just as critical as managing human users.
That's a great breakdown. So we've secured the front door. Let's move to the second topic in this core domain, core objects and organization configuration. If Entra ID is the foundation, the various admin centers are the control rooms for your environment. We have the Microsoft 365 Admin Center, which is the top-level interface. Think of it as the master switchboard. This is where you configure foundational org settings and domain names. If your company's domain isn't verified here, nothing else works correctly. Then we have the Exchange Online Admin Center, where we manage mailboxes, mail flow, and distribution lists.
And for anyone managing this ecosystem, it is vital to understand how these objects interrelate, particularly through the mechanism of licensing.
Licensing is huge.
The license types assigned to users and groups fundamentally dictate access to M365 features, including Copilot. You can have a user perfectly provisioned in Entra ID, sitting in the right groups, fully authenticated. But if they're only assigned a basic Exchange Online Plan 1 license, they're not going to have access to Microsoft 365 Copilot or any of the advanced SharePoint features.
It's the master switch.
Licensing is the master switch that lights up the capabilities within these downstream admin centers.
Let's dissect SharePoint and Teams, because these two services are where Copilot really does its heavy lifting. It's where the data lives. In the SharePoint and Microsoft 365 Admin Center, administrators manage the architecture, sites, document libraries, folders, and most importantly, roles and permissions.
And in the Teams Admin Center, you are managing teams, standard and private channels, and communication policies.
When a user queries Copilot, Copilot uses the data resting within these specific structures to generate its responses.
This is where we need to dive into a case study on object interaction, because this scenario trips up so many administrators on the exam and in the real world. Let's look at this setup. You have a user, they have a premium Microsoft 365 license, which explicitly includes Copilot. They're also part of a massive company-wide distribution list managed over an Exchange. However, this user lacks explicit roles and permissions for a specific, highly confidential SharePoint site that is connected to the organization's executive leadership team. The user goes into Copilot and asks it to summarize the Q3 financial projections. Now, those projections are stored exclusively on that secure executive SharePoint site. What can Copilot see?
The answer is absolutely nothing from that secure site. Zero. Copilot honors SharePoint permissions strictly, natively, and universally. The user's membership in a broad Exchange distribution list, or even their access to a general company-wide Teams channel, does not magically bypass the explicit restrictions set on that specific SharePoint site or its document libraries.
It's an airtight boundary.
Copilot operates entirely within the security context of the user asking the prompt. If the user cannot natively open SharePoint, search for that document, and open it themselves, Copilot will pretend it does not exist.
That is the crucial takeaway you have to remember. Copilot does not have its own super user God mode access that circumvents user permissions. It acts as the delegate of the user. Therefore, configuring the appropriate roles like site owner, site member, or site visitor in SharePoint is the direct, primary mechanism for controlling what Copilot can utilize as grounding data.
I'm thinking of a loophole here, specifically around how these admin senders overlap. What about the edge cases for this? You mentioned SharePoint and Teams, which we know are deeply integrated behind the scenes. What happens when conflicting Teams policies and SharePoint roles create visibility gaps for Copilot?
The private channel conundrum. This is a brilliant edge case to explore. When you create a standard channel in Microsoft Teams, it simply creates a folder within the underlying SharePoint site's main document library. It shares the permissions of the parent site.
Simple enough.
But when a user creates a private channel in Teams, Microsoft does something different. It provisions an entirely separate, lightweight SharePoint site, specifically for that private channel. That new site has its own distinct permissions that are managed strictly through the Teams interface, not the main SharePoint site interface.
So they get disconnected.
The edge case occurs when an IT admin tries to audit permissions from the main SharePoint admin center. They look at the main site, see it's locked down, and think a sensitive document is secure. But they fail to realize a user has been added to a private channel in Teams where a copy of that sensitive document resides.
Oh, wow.
If the user has access via the private channel, Copilot will absolutely find it. The conflict between centralized SharePoint management and decentralized Teams private channel management is a major visibility gap that admins must proactively monitor.
That is a massive gotcha for the exam. You have to check both admin centers. All right, wrapping up our first section, we need to look at threat protection intelligence. This introduces a major player, Microsoft Defender XDR.
Defender XDR, which stands for Extended Detection and Response, moves us beyond just managing identity and file access. It provides active threat protection and intelligence across the entire Microsoft ecosystem. It covers endpoints, cloud apps, email, and identity.
It's everywhere.
Its superpower is that it correlates signals from all these different domains. This is critical because Entra ID might look at a login and say, the identity checks out, MFA was successful, the user is safe. But Defender XDR might detect that the specific laptop the user is working on is actively executing a suspicious PowerShell script and has been compromised by malware.
Let's do a quick case study on how Defender integrates with our AI. How exactly does Copilot use controls in Microsoft Defender to protect against these active risks?
Copilot natively leverages the real-time threat intelligence generated by Defender. Imagine a scenario where Microsoft Defender for Office 365 identifies a malicious zero-day payload hiding in an email attachment. Or perhaps Defender for Endpoint flags a Word document downloaded from the web as exhibiting ransomware-like behavior.
It flags it immediately.
Defender immediately isolates or flags those files in the system. When a user issues a prompt to Copilot, Copilot respects those Defender controls. It will absolutely refuse to summarize, ingest, or interact with a file that Defender has classified as a threat. Think of Defender as the organization's active immune system, and Copilot is programmed to refuse to process infected cells.
Okay, but what if the systems disagree? What about the edge cases for this? Let's say we have a scenario where Defender flags a device as a high threat because it detects suspicious lateral movement on the network. But the user's Entra ID identity secure score is still perfectly high because they haven't failed any MFA prompts recently. What happens then?
This edge case perfectly highlights why deep architectural integration is everything. If these systems were siloed, the user would still be able to access Copilot because Entra thinks everything is fine. But when properly configured in a modern M365 environment, Defender XDR continuously feeds its device risk signals directly into Entra ID conditional access.
So it forces a reevaluation.
Exactly. Even though the user's identity itself hasn't shown risky sign-in behavior, the device risk signal coming from Defender forces Entra ID to dynamically reevaluate the session. Entra ID sees the high device risk, and based on the conditional access policy, it will instantly revoke the SSO token.
It just cuts them off.
It drops the session. It blocks access to all M365 services, including Copilot, until that device is remediated by the security team. The edge case proves that managing identity alone isn't enough. You need the XDR signal to reach out and cut off the AI's access when the endpoint is compromised.
That perfectly transitions us into our second major domain. If you are keeping track, this section represents a massive 40% of our exam focus, data protection and governance. We like to call this building the Copilot guardrails.
This is where things get Intensely granular.
Extremely. So far, we've locked down the front door with Entra ID, but once a user is inside the house, what's stopping Copilot from rummaging through the executive's desk drawers? That brings us to the colossal suite of tools known as Microsoft Purview.
Microsoft Purview is the overarching umbrella brand for all of Microsoft's data governance, risk, and compliance solutions. For anyone administering Copilot, it is arguably your single most important tool set.
It's massive.
The suite is massive. It includes information protection, data loss prevention, commonly known as DLP insider risk management, communication compliance, data security posture management for AI, which we'll refer to as DSPM for AI, and data lifecycle management.
Now, to truly understand why Purview is so essential, we have to pause and explain how Copilot actually accesses data. Copilot relies heavily on a foundational technology called the Microsoft Graph.
Yes, a graph is everything.
The best way to understand the graph is to realize it is not a traditional relational database. It is a massive, dynamic, continuously updating map of relationships. It maps nodes and edges. It maps who you are, who you report to, what meetings you attended yesterday, what emails you sent this morning, and what documents you've worked on or simply have access to.
And it builds a semantic index.
Right. The graph builds what Microsoft calls a semantic index. This index is what allows Copilot to understand the context of your prompt and retrieve incredibly relevant grounding data at lightning speed.
And that speed, combined with that staggering reach, is exactly why Purview must act as the ultimate set of guardrails. Because the graph is so devastatingly efficient at surfacing everything a user technically has access to, organizations must implement robust data classification.
What does that look like in practice?
Data classification in Purview is the process of scanning your entire digital estate and automatically identifying sensitive information. Things like credit card numbers, passport data, health records, or highly confidential proprietary project code names. Once the system identifies that data, we use sensitivity labels to apply protection.
Let's run a detailed case study on sensitivity labels because understanding this workflow is guaranteed to be tested. Picture a user in the marketing department. They are prepping for a cross-departmental sync, and they ask Copilot to summarize a highly confidential financial report that was accidentally left in a broadly accessible folder.
The classic mistake.
Now, the file itself has a sensitivity label applied to it via Purview information protection. This specific label restricts viewing to members of the finance team only, and it applies heavy encryption to the file. The user asking the prompt is definitely in marketing, not finance. What exactly happens under the hood?
This is where the magic of Purview and Copilot integration truly shines. When the marketing user asks the prompt, Copilot immediately queries the graph to find the relevant data. The graph locates the financial report because the folder permissions are technically open.
So it finds the file.
It finds it, but before Copilot ingests a single word of that content, it intercepts the sensitivity label and the encryption metadata wrapped around that file. Copilot reads the label's requirements, which dictate that the user must possess a decryption key granted only to the finance team.
And since they are in marketing,
It checks Entra ID for authorization, sees the user is in marketing, and therefore Copilot's denied access to the decryption key. Copilot cannot read the file. Therefore, Copilot simply returns a message to the user stating that it cannot summarize the document due to permission restrictions. It proves definitively how Copilot uses granular controls in Purview to protect against risks dynamically, even if the folder permissions were sloppy.
hold on, let me throw an edge case at you. We just talked about information protection, which is about labeling data. But what about data lifecycle management, which is about retaining or deleting data? What about the edge cases for this? What happens when Copilot tries to access a document at the exact millisecond a retention policy mandates its deletion? Who wins that fight?
That is a fascinating race condition edge case. Data lifecycle management dictates the lifespan of your data, how long we are legally required to keep it, and when we are legally required to destroy it. Let's say a strict retention policy hits its expiration timer and triggers an automated deletion process for a specific file.
Okay, it's scheduled for deletion.
That document is immediately removed from the active SharePoint library. Depending on your configuration, it might be moved to a preservation hold library if an e-discovery hold is active, or it might be permanently purged. If Copilot is right in the middle of generating a complex response utilizing that exact file, the Microsoft Graph will instantly register the loss of access. Instantly. Copilot will gracefully fail the summarization of that specific file. It ensures that deleted or expired data is not inadvertently immortalized or leaked in an AI chat response. In the Microsoft 365 architecture, the governance policy always wins the race.
That is incredibly robust engineering. Moving to our next topic within data protection, identifying and mitigating governance risks. We have this massive purview suite available to us, but how do admins actually use it on a daily basis to find the needle in the haystack?
You need visibility.
We have a few primary tools for visibility. First is Compliance Manager. This gives you an overall dashboard score and step-by-step recommendations for meeting complex regulatory standards like GDPR in Europe or HIPAA in healthcare. Then we have Data Explorer. Think of this as a visual map allowing you to drill down and see exactly where your sensitive information physically lives across SharePoint sites, OneDrive accounts, and Exchange mailboxes.
And finally, we have Activity Explorer.
Right. Activity Explorer lets you track what users are actually doing with that sensitive data. Are they printing it? Are they trying to downgrade the sensitivity label? Are they copying it to an unencrypted USB drive?
And those visibility tools feed directly into your active response mechanisms. Administrators use data loss prevention, or DLT, to set up automated reactive rules. For instance, if a user tries to email a spreadsheet containing 50 credit card numbers to a personal external Gmail address, a properly configured DLP policy will intercept that action, automatically block the email from sending, and generate a high-priority alert for the security team to investigate.
What about internal threats?
That's where communication compliance comes in. It works on a similar principle but focuses on text and context rather than specific data types. It leverages machine learning to identify toxic language, targeted harassment, or clear corporate policy violations occurring in Teams chats or internal emails. It's an increasingly crucial tool for HR and legal teams to maintain a safe and compliant workplace environment.
But the newest tool in the Purview arsenal, and perhaps the most heavily tested on the AB-900 exam, is DSPM for AI, Data Security Posture Management for AI. Why is this specific tool so critical right now?
DSPM for AI is critical because it represents a paradigm shift. It is designed specifically to discover and manage AI activity natively. Think about the difference. Traditional DLP looks at data moving horizontally, data trying to leave the company via email or USB. DSPM for AI looks at how data is interacting vertically with the AI engine itself. It provides a specialized dashboard that helps administrators answer urgent questions like, are my developers feeding highly confidential proprietary source code into Copilot prompts to debug it? It is tailored entirely to the unique risks introduced by generative AI, ensuring that users are actually adhering to the company's responsible AI principles.
Let's bring this to life with a comprehensive insider risk and discovery case study. Imagine an admin gets a tip. They suspect an employee who recently handed in their resignation is utilizing Copilot to systematically scrape proprietary client lists, pricing models, and strategic data before they leave to join a competitor. How is this investigated from start to finish within Purview?
This is a textbook high-stakes scenario. First, the admin leverages insider risk management in Purview. Insider risk uses machine learning to establish a baseline of normal, everyday behavior for that specific user. Suddenly, the system notices a massive anomalous spike.
What kind of...
The user is downloading an unusual volume of files, and specifically, they are utilizing Copilot to summarize and extract data from hundreds of strategic documents they haven't interacted with in months. This deviation from the baseline generates a high-severity alert.
So the admin reviews the alert and realizes the threat is credible. They need to escalate.
Correct. They immediately move to Purview eDiscovery to create a formal case. Within eDiscovery, they perform what's called a content search. They scope this search extremely tightly. They target the specific user's Exchange mailbox, their personal OneDrive, and critically, their team's Copilot interaction history over the last 2 weeks.
So they can see the prompts.
Exactly. The content search parses the system and retrieves the exact text of the prompts the user submitted to Copilot, as well as the specific files Copilot referenced to generate the responses. The admin can then place a legal hold on all of that data, preserving it cryptographically so it cannot be deleted or altered, preparing it for formal HR or legal action.
Okay, but what if the user is smart? What about the edge cases for this? We are talking extensively about Microsoft 365 Copilot, which is inside our walled garden. But what if users are bypassing native Copilot entirely and interacting with unapproved third-party AI tools, so-called shadow AI? They are pasting sensitive data into a public web chatbot. Can DSPM for AI handle that?
This is a major real-world concern for CISOs. If users are bypassing Copilot and pasting sensitive corporate data into external public AI chatbots, they are actively breaching corporate data boundaries, often unwittingly feeding public AI training models.
How do we stop it?
While DSPM for AI is deeply integrated with Microsoft 365 Copilot, Microsoft addresses this external edge case by integrating Purview with Microsoft Defender for cloud apps. Through cloud app security, administrators can discover the shadow use of thousands of unsanctioned third-party AI applications occurring on corporate devices.
You can just block them.
You can configure conditional policies to either block access to those specific external AI URLs entirely, or, using Endpoint DLP, you can prevent users from using the copy-paste function to move corporate data into the browser windows of those specific external AI tools. It creates a comprehensive safety net.
That is a phenomenal defense-in-depth strategy. Now, we have to tackle topic 3 in this data protection section, which is arguably the biggest nightmare for any IT admin deploying AI, the threat of oversharing in SharePoint. I always joke that we've all seen the nightmare scenario. The SharePoint site created 5 years ago with permissions set to everyone except external users. It's the IT equivalent of leaving the company vault wide open and taping a map to it on the front door.
It is absolutely the #1 challenge organizations face when deploying Copilot. Oversharing occurs when permissions on a SharePoint site, a document library, a folder, or an individual file are far too broad. In a pre-AI world, security through obscurity kind of worked. If an intern didn't know the specific URL to the HR folder, they wouldn't go looking for it. The data was overshared, but it was practically hidden.
But as we discussed earlier, the Microsoft graph destroys the concept of security by obscurity. Because the graph aggressively indexes and connects all accessible data, if an intern has accidental read access to that HR folder, Copilot doesn't care that they don't know the URL.
It doesn't need the URL.
Right. If the intern innocently asks Copilot, "What is the average salary of the marketing team to help me plan my career?" Copilot will instantly query the graph. See, the intern technically has read access to the overshared HR spreadsheet and happily present the highly confidential payroll data right in the team's chat window.
Exactly. And the critical insight here is that this isn't a Copilot failure. Copilot is functioning perfectly. It is an underlying governance failure that Copilot simply exposes immediately. Copilot holds a mirror up to your bad governance.
So let's walk through the case study on curing oversharing. An organization deploys Copilot on a Monday. By Monday afternoon, a junior employee suddenly sees executive payroll data synthesized in a Copilot response. Absolute panic ensues across the C-suite. How do we systematically fix this?
First, you execute immediate damage control. You identify the source file Copilot referenced, and thankfully, Copilot always provides citations for its data. You go to that specific SharePoint library and restrict its permissions manually to stop the immediate bleeding.
But that's just a Band-Aid.
Right. To fix this systemic underlying issue, the administrator must run a data access governance report in the SharePoint Admin Center. This report scans the entire SharePoint environment and intelligently identifies sites that have the highest number of sensitive files that are broadly accessible to the organization.
So it highlights the worst offenders.
Once these overshared libraries are located, the admin utilizes SharePoint Advanced Management features. Specifically, they configure a powerful feature called Restricted Site Access. This control allows an admin to lock down a SharePoint site so that only members of a specific defined Microsoft 365 group can access it. This action entirely overrides any broad sharing links or legacy everyone permissions that might have been applied previously by careless site owners.
Hold on, I see a potential flaw in that fix. What about the edge cases for this? You lock down the site using restricted site access. It's locked to the finance group. But what happens when an authorized user inside that restricted site decides to share an individual file directly with an unauthorized user outside the group? They click Share, type in the marketing intern's name, and hit Send.
The Restricted Site Access feature in SharePoint Advanced Management handles this specific edge case beautifully. When a site is configured with a restricted access control policy, it acts as an absolute hard boundary.
So the link just dies.
Even if a site owner or an authorized finance member generates a direct item-level sharing link for a specific document and emails it to someone who is not in the approved Microsoft 365 group, that link will simply not work. When the recipient clicks it, they will get a hard access denied error. The site-level restriction forcefully supersedes the item-level sharing attempt, effectively stopping the oversharing hemorrhage at the source, regardless of user behavior.
That is a life-saving feature for admins. It takes the human error out of the equation. All right, we are moving into our final major domain, Section 3, Copilot Administration and the Agent Lifecycle. This makes up the final 25% of our focus. We've secured the identity foundation, we've built the massive data guardrails, now let's actually administer the AI itself. Topic 1 is Copilot features, licensing, and prompts. Let's start by clarifying the fundamental difference between built-in capabilities and agents.
The built-in capabilities of Microsoft 365 Copilot are what users experience out of the box in their daily applications like Word, Excel, PowerPoint, and Teams. It's the ability to draft an email reply, summarize a long email thread, or generate a slide deck based on standard Microsoft Graph data. It's a generalized assistant.
And agents are different.
Agents, which we will dive into deeply in a moment, are targeted, customized AI assistants built to perform very specific workflows or access specialized external data sets that the standard Copilot doesn't natively reach.
And to get access to either of these, administrators need to navigate the licensing models. For the core Copilot experience, organizations typically use the Copilot monthly license model. This is a standard per-user, per-month subscription. You assign these licenses just like you would an Exchange or Teams license. You can do it manually via the Microsoft 365 Admin Center, or much more efficiently using Entra ID group-based licensing.
However, there's also a pay-as-you-go model that admins must actively manage, particularly regarding advanced SharePoint integrations and certain custom AI capacities. With the pay-as-you-go model, the organization links their Microsoft 365 tenant directly to an Azure subscription.
When do you use that?
This billing method is utilized when users exceed standard capacity limits or when they utilize advanced features like complex document processing and data extraction within SharePoint Premium. The why here is crucial for the exam and real life. Admins must monitor these pay-as-you-go billing policies rigorously within both the Azure and Microsoft 365 admin centers.
Because it can get expensive.
Extremely. If left unmonitored, a highly active custom agent processing thousands of complex documents daily could generate massive, unexpected cost overruns for the IT department.
Tracking that usage is done through Copilot Analytics, which is accessible via the Microsoft 365 Admin Center. Copilot Analytics provides incredibly detailed dashboards showing adoption rates, active users, and, crucially, how Copilot is impacting overall productivity. But administration isn't just about monitoring billing and usage, it's about active enablement. Let's look at a feature and prompt management case study. Suppose an organization wants to standardize how its massive 500-person sales team interacts with Copilot to ensure they are getting the best, most consistent possible client summaries before a pitch. How does an admin facilitate this?
The admin can take a very proactive role here. First, they can use configuration policies in the Microsoft 365 Admin Center to identify and configure which specific Copilot features to enable or disable for that specific sales group. Maybe they want to disable Copilot in Excel for now to prevent confusion, but ensure it's heavily integrated and enabled in Teams.
And what about the prompts themselves?
More importantly, the admin can manage prompts centrally. Instead of 500 salespeople wasting time trying to invent the perfect prompt to summarize a client history, the admin, perhaps working with a sales leader, can create a highly optimized, tested prompt. They save it and share it directly to the prompt library for the entire sales team. They can even schedule prompts or delete outdated ones. This ensures consistency, saves time, and maximizes the return on the AI investment.
All right, time for my favorite question. What about the edge cases for this? You mentioned scheduling prompts. What happens with the nuances of responsible AI principles when an admin schedules automated prompts that might generate customer-facing content without a human reviewing it first?
This is a critical governance and ethical edge case. The core, unshakable tenet of Microsoft's responsible AI principles is that humans must remain in the loop. If an admin schedules a prompt to automatically generate weekly account summaries and configures an automated flow to email those summaries directly to external clients, they are operating in a highly risky edge case.
Because Copilot can hallucinate.
Copilot is a generative AI. It can and will occasionally hallucinate or misinterpret data. If it hallucinates a massive discount in an automated email to a client, you have a major business problem. The administrative solution is to design the workflow so that the scheduled prompt delivers its output to an internal Teams channel or a draft folder first.
So a human has to approve it.
This architectural decision enforces a mandatory human review cycle before the AI-generated content is externalized. Administrating Copilot isn't just about making workflows faster. It's about enforcing safety boundaries on automation.
That is a brilliant point. Let's move to our final topic, and frankly, the most exciting part of this new ecosystem, the agent lifecycle, from creation to approval. We mentioned agents earlier. Let's outline the primary use cases because you need to know which tool to reach for. We have the researcher agent, the analyst agent, and fully custom agents.
The distinction between these is very important for the exam. A researcher agent is primarily designed for information retrieval and synthesis. Its
Mhm.
primary use case is scouring vast amounts of reference material, like an entire corporate repository of standard operating procedures or HR policies, and providing highly accurate, cited answers to user questions. Think of it as a highly focused internal search engine.
Okay, and the analyst agent.
An analyst agent goes a crucial step further. It doesn't just retrieve, it processes. You point an analyst agent at a complex data set, like a massive spreadsheet of regional sales figures, and ask it to identify trends, perform complex calculations, and generate visual charts. You choose an analyst over a researcher based entirely on your data processing needs. Do you need to find text, or do you need to crunch numbers?
And the fully custom ones.
And then, of course, you have fully custom agents. These are built using Microsoft Copilot Studio to perform highly specific multi-step workflows, like interacting with the user to gather information and then automatically initiating an IT help desk ticket, or querying a third-party CRM system via an API.
So how is a custom agent actually born and deployed? Let's walk through the agent deployment lifecycle case study. A department head uses Copilot Studio to build a custom agent designed to parse complex 100-page vendor contracts. They test it, it works perfectly in their localized test environment. How does it actually get into the hands of the end users across the department?
It absolutely does not happen automatically, and for very good reason. Once the department head creates and finalizes the agent, they must publish it. But clicking Publish just sends the agent into a queue. It must go through a strict, centralized administrative approval process.
The admin has to intervene.
The Microsoft 365 administrator receives a notification that a new custom agent has been submitted for tenant-wide or group usage. The admin must review the agent's architecture. What data sources does it access? What specific actions can it take on behalf of the user? They must determine if it complies with corporate security and data handling policies.
So they review it, verify it's safe, and approve it in the Microsoft 365 Admin Center. What next? Is it live?
Almost. Once approved, the admin must then configure user access, defining exactly which users or security groups that are actually allowed to interact with the agent. But the administrator's job isn't done after deployment. The admin's role immediately shifts to continuous monitoring. They have to use both the Microsoft 365 Admin Center and the Microsoft Power Platform Admin Center.
Why the Power Platform?
Because Copilot Studio is fundamentally built on the Power Platform architecture. The Power Platform Admin Center is where you go to monitor the agent's lifecycle in depth, track its granular usage metrics, and gather deep operational insights, like exactly how many times it was invoked today and whether it's experiencing any API error rates.
I'm looking for the trapdoors again. What about the edge cases for this? What happens to those operational insights if the Power Platform Admin Center experiences a telemetry sync delay with the M365 Admin Center? Or worse, if the underlying data sources the custom agent relies on are accidentally deleted by a user?
If there's a telemetry sync delay between the Power Platform and M365 Admin Centers, which can happen, the M365 usage reports might temporarily show zero activity for the agent. This could cause an admin to mistakenly think the agent is abandoned and potentially unpublish it. The administrative best practice is always to verify metrics directly in the Power Platform environment for the most real-time, accurate data.
What about the deleted data sources?
The second scenario, deleted data sources, is the real critical edge case. If the custom agent is pointed at a specific SharePoint library to parse those vendor contracts, and a site owner accidentally deletes that entire library, the agent itself doesn't disappear. It remains active in the Copilot interface. However, when a user prompts it, the agent will throw an operational error, as it is unable to complete its workflow.
So the admin has to catch that.
Admins must proactively monitor the Operational Insights dashboard specifically for these failure rates. Spikes in failure rates identify when an agent's grounding data has been compromised or removed, requiring the admin to step in and either update the agent's data source connection or deprecate the agent entirely to prevent user frustration.
It's all about proactive monitoring.
Exactly. If we synthesize this entire journey we've just taken, the massive architecture of an AI-enabled Microsoft 365 environment becomes remarkably clear. Everything starts by building an unshakable zero-trust identity foundation in Entra ID. You simply cannot protect the data if you don't first secure the user and the device.
That's the bedrock.
Then, and only then, do you erect the massive purview and sensitivity label guardrails to prevent the Microsoft Graph from causing catastrophic oversharing. Only when the identity is secure and the data is classified do you move into the active management layer, handling the licensing, the prompt scheduling, and the rigorous lifecycle and approval processes of Copilot and custom agents.
It is a massive, complex undertaking, but as we've seen throughout this deep dive, the tools are incredibly powerful if you know exactly how to wield them. I want to leave you with a final provocative thought. Throughout our discussion today, the concept of DSPM for AI data security posture management really stood out to me. Its entire job is to constantly monitor and discover AI activity to enforce responsible AI principles. But it raises a profound question. If the system is constantly monitoring the humans to ensure they behave ethically with the AI, who is monitoring the monitors? As AI agents like the researcher and analyst become more complex and increasingly autonomous, making decisions, executing workflows, and synthesizing data on their own, the IT administrator's role is fundamentally shifting. You are no longer just a traditional systems manager assigning licenses and resetting passwords. You are becoming an AI ethics and governance enforcer. You are the one who determines the boundaries of machine autonomy within your organization. That is a fundamental structural change in what it means to be an IT professional today.
It is a complete paradigm shift, and mastering the fundamentals we covered today is the absolute only way to prepare for it.
Exactly. To the learner out there prepping for the AB-900 exam or just trying to secure their own tenant, trust your training, keep digging into your own systems, and never take any permissions for granted. The landscape is changing incredibly fast, but you now have the map. Keep exploring, and we'll catch you on the next deep dive.